Okay, this video is about formal charge and how to find formal charge. And so you can look up in a textbook or somewhere, and they give you this formula here, and they got the formal charge of an atom is equal to the total number of valence electrons minus the total number of non-bonding electrons minus 1/2 the total number of bonding electrons. Now you can memorize that formula if you want, but I just like to think of it this way, is that the way that you do it is to think about like the electrons expected minus the electrons shown. That's how I keep it in my head when I do formal charge. So let me give you an example. Oh, there is one important thing though. The sum of the formal charges should in a molecule or an ion must equal the charge on the molecule or the ion. So anyway, let me just show you what I mean here. So let's say you were to do carbon dioxide. And so you go ahead and you draw the Lewis structure for carbon dioxide. And so you start and let's see, I'm going to make it black here. All right. So you go carbon in the middle, and then I'm not going to go through how to draw the Lewis structure, but anyway, you would end up with something like this right here. Okay, so the formal charge. Now, each atom in a molecule has its own formal charge. So it's not like the total formal charge. It's each atom has its own formal charge. So let's just start with this oxygen right here. Okay, so this oxygen right here has 6 valence electrons. If you know how to figure that out, I guess you can look at the periodic table. All right, now we're going to count how many electrons are being shown or around this oxygen. So we're going to take the electrons expected, which is 6, those are the valence electrons, minus the electrons shown. Now I'm just going to number them. So there's 1, 2, 3, 4. So there's 4 electrons shown, but each bond, 2 of these electrons are from oxygen. So 1, 2, 3, 4, 5, 6. So 6 minus 6 equals 0. So the formal charge on this oxygen is 0. Now normally they write a little number by it, but if it's 0, a lot of times they omit it. I'm just going to write it right here just to show you that's where it's at. Okay, now let's do this carbon right here. So carbon has 4 valence electrons. Now let's count how many electrons are around carbon. So there's 1, 2, 3, 4. So electrons expected is 4 minus electrons shown. I can number them 1, 2, 3, 4 minus 4, and that equals 0. So carbon's formal charge is 0. Okay, now let me just do this oxygen, although you can see it's exactly the same as this oxygen over here. So basically it's going to be 6, oops, I don't want that, 6 minus 1, 2, 3, 4, 5, 6. So that's also going to be 0. Now, let's say, for example, somebody drew carbon like this or carbon dioxide like this. Now, it would work. You could get a Lewis structure that everything follows the octet rule. You could draw carbon dioxide like this, and I've seen people do it before. Now, anyway, let's say you were doing the formal charge on this carbon dioxide. So let's start with the oxygen here. So oxygen has 6 valence electrons. Let's count how many are shown. 1, 2, 3, 4, 5, 6, and then there would be 1 there, so that would be 7. So 6 minus 7 equals -1. So this oxygen has a -1 formal charge. Okay, carbon has 4 valence electrons, and let's count how many are shown. 1, 2, 3, 4. So 4 minus 4 is 0. So this carbon's formal charge is 0. Okay, let's do this oxygen. 6 valence electrons. Let's count how many are shown. 1, 2, 3, 4, 5. and 6 minus 5 equals positive 1. So with formal charges, you need to put the signs. So this is positive 1. Now, as you can see, the sum of the formal charges of the atoms in a molecule or ion must equal the charge. So a minus 1 does cancel out a plus 1 to give the overall molecule 0 charge. But there are other rules we'll talk about in a minute about how to determine like how formal charge can be used to figure out which structure is the best. Okay, so here let's just do an ion. So let's do carbonate, the carbonate ion. So C double bond O, we'll put the double bond there, and in that right there. So then we'll put the lone pairs on there. And for some reason I drew this one in red, so I'll count the formal charges in black. Okay, so this is the carbonate ion if you were to draw the Lewis structure for it. Okay, now it has a 2 minus charge. So let's do each atom. So oxygen, this oxygen over here, has 6 valence electrons, and 6 minus 1, 2, 3, 4, 5, 6, and then 7 right there. So 6 minus 7 equals a negative 1. So this oxygen would be a negative 1. Okay, now notice that this oxygen is the same as this one over here. So it's also a negative 1. You don't have to count it. Okay, count it up. Let's do this oxygen down here. Okay, 6 valence electrons. The electrons expected minus 1, 2, 3, 4, 5, 6. So 6 minus 6 is 0. So this oxygen is 0. Okay, carbon, it has 4 valence electrons minus 1, 2, 3, 4. So 4 minus 4 is 0. So carbon is 0. Now, the rule is the sum of the formal charges must equal the charge on the ion. Okay? Look at the ion is a 2 negative ion. And if you take the sum of the formal charges, it also equals 2 negative. So that has to be true. Okay, now, sometimes it's possible to end up with more than one Lewis structure. So this one is for H2CO. And I got to finish drawing the Lewis structure here. So there's 2 valence electrons plus 4 plus 6. So my picture has to show 12 electrons. So if you draw the Lewis structure, you would see 2, 4, 6, 8, 10, 12, 14. So that's too many. So we're going to need a double bond right there. And then we can erase a lone pair. Let's see here. I got to click on the eraser. So we wouldn't need a lone pair there. And right there. Now I kind of erased my double bond. So let me go back and put that in there. Okay, so there has to be a double bond right there. And you would notice the same thing over here. And then there would be a lone pair here, lone pair there. Okay, let me darken up these lone pairs a little bit. Okay, now let's do the formal charges on these things right here. So hydrogen has 1 valence electron and 1 electron is shown, so its formal charge is 0. Okay, carbon has 4 valence electrons. Let's count how many are shown. 1, 2, so 1, 2, 3, 4, 5. So that's going to be negative 1. So the carbon's formal charge is negative 1. Let's do oxygen. It has 6 valence electrons. 1, 2, 3, 4, 5. So 6 minus 5 is positive 1. So the oxygen is positive 1. Hydrogen, whenever it just forms a single bond, it's always 0 because it's 1 minus 1. Okay, so the carbon's negative 1, the oxygen's positive 1. Now let's go over here. All right, so anytime hydrogen, it's just 1 minus 1, so it has a formal charge of 0. This has a formal charge of 0. Now let's do carbon. 4 valence electrons minus 1, 2, 3, 4. So 4 minus 4 is 0. Okay, oxygen, 6 valence, 1, 2, 3, 4, 5, 6. So 6 minus 6 is 0. So this is 0. So now you could have this H2CO, and there's a rule to figure out which structure is the best structure, or sometimes they call it the most plausible or the preferred structure. So you got to go through these rules. For neutral molecules, a Lewis structure in which there are no formal charges is preferable to one in which formal charges are present. So see, this structure right here would be the best structure. Okay? So that's just a way that formal charge can be used. So I'm going to have a second video that goes through a couple more of examples of how to figure this out.